What's going on, Algebra 1 students? Mr. Ford here with another homework tutorial. Today we are, hang on, wait a minute, there we go. Today we're looking at homework for 3.2.4, problems 370 through 375. What we're going to do here in the first question is we're going to use generic rectangles, or not, to multiply the following expressions. We already did problems A and B as part of class in first hour today, so if you weren't in that class, you can now pause this video to check those answers. I did A with a generic rectangle. I did B without. I'm going to do C and D both with. I think this is an important skill for us to practice leading up to where we're going with this. So for question C, let's go ahead and set up a generic rectangle. Just draw a box with a plus sign in it. You can go ahead and put the dimensions along the sides there. It doesn't matter which side you go on. 12x plus 1 are along there. X squared, just make sure that's a minus 5 there because of it's x squared minus 5, so make sure there's that. And all we're going to do now is multiply what's going on. 12x times x squared will be 12x to the third power. 12x times negative 5 is negative 60x. 1 times negative 5 is negative 5, and 1 times x squared is just x squared. So remember what's going on here is we're just actually just kind of double distributing the 12x and then the 1. So take your time with it. 12x to the third plus x squared minus 60x minus 5 is the best way to write that answer. Standard form for algebra problems has the highest degree first, and then going down second power, first power, and 0 power right there. Question D, we'll do this again on the generic rectangle for this one. 3 minus 5y, I'm going to put down here, and on the side I'm going to put 2 plus y over there. Again, make sure the negatives are negative, negative 5y. And now we multiply. 3 times 2 is 6. 3 times y is 3y. Negative 5y times y is negative 5y squared. And 2 times negative 5y is negative 10y. There you go. And now all we got to do is add it all together. We'll put the negative 5y squared in front. We're going to combine together negative 10 plus 3 to make negative 7y, and then finally plus 6. That is, again, the best answer for this. Next question, we're going to find a rule represented for the pattern at right. This is kind of a weird question, but what I believe we're supposed to think is here that figure 1 has 11 boxes. So the point 1, 11 would be on this line. I also think that the point, let's see if I'm looking at this, that's 3 to the right and 1, 2, 3, 4, 5, 6, 7 up. So I believe this is the point 3, 7 right there. So I think based on that information, we're going to use these 2 points to find the rule, which is another word for the equation. So we've done this a lot in the past, but we're going to use these 2 points to figure out the equation of the line. The first thing we need is the slope. The slope is going to be 11 minus 7. Again, I'm subtracting the y's here. 11 minus 7 and 1 minus 3. I got to go in order there. 1 minus 3. 11 minus 7 gives us 4. 1 minus 3 gives us negative 2, and that's going to divide out to be negative 2. That will be the slope of our equation. Again, our equation is going to be in the form y equals m times x plus b. That's going to be the m in our equation. As far as b goes, I'm going to use that formula we haven't talked about in a while. It's y minus m times x. Another way to think about this is if figure 1 has 11 tiles and we're going down by 2 each time, then I kind of know that figure 0 has to have 13 tiles because I'm going to go back up 1 space, but I'll use y minus mx anyway. For b, let's see, for y, I'm going to choose 11. For the slope, I know that's negative 2. And the x is 1. So this ends up being 11 minus negative 2, which is 13 anyway, and there you go. So the equation would be y equals negative 2x plus 13. There you go. 372, Harry the hippo is munching on lily pads in his pond. When he arrived at the pond, there were only 20 lily pads. He is eating 4 lily pads an hour. Henrik, the hunger hippo, found a better pond with 29 lily pads, and he eats 7 lily pads per hour. If they start eating at the same time, when will their ponds have the same number? I'm going to highlight that, of lily pads remaining. Well, let's think about these 2 hippos. Harry, He has 20 lily pads and is eating 4 an hour. So the first equation is going to be 20 minus 4x, because he had 20 lily pads, started there, and is removing or eating 4 of them every hour. The other hippo, Heinrich, he has starting with 29 and is eating 7. So that would be 29 minus 7x. And since we want to know when these things have the same number, we're going to slap an equal sign in between them, and now we can solve this problem algebraically. That's the best way to do this. From here, if you just look at this algebra problem for a moment, you got to think about what steps you want to take. It's all about moving the tiles from side to side until you have x equals a number. I would personally start by adding 7x to both sides. The 7x plus 7x cancels out, and we have 20 plus 3x equals 29. Next, we'll subtract 20 unit tiles on both sides. 20 minus 20 will cancel out, and we'll have the 3x equals the 9 right there, and then we'll divide those 9 tiles into 3 equal piles, and we'll have 3 in each pile. There you go. I like to use the tile analogies because I think it's important. That means it's going to be 3 days, because the question is, when will the pounds? And it's in days. 3 days. How many lily pads will be left in each pond at that time? Well, we could use either 20 minus 4x or 29 minus 7x. It actually shouldn't matter because both of them should be the same when x is 3. That's kind of the whole point of that equation that we just solved. So 20 minus 4 times 3 would be 20 minus 12, and that is 8 lily pads. I'll just point out that 29 minus 7 times 3 is 29 minus 21, which is also 8. So it doesn't matter which one you choose. 373, we're going to graph each equation below on the same set of axes and label the point of intersection with its coordinates. So we're going to graph 2 lines and find the intersection. Let's start with 2x plus 3, which is going to start with a y-intercept of 3 right there on the y-axis, and has a slope of 2 over 1. Might think about it that way. So we're going to go to the right 1 up 2 to make this line happen. Over 1 up 2. You'll see the line develop pretty quick once you graph that, and it gets to be looking a little bit like this. Of course, since we're looking for the intersection, this might be a good one to use a ruler on, because the intersection is not going to happen unless we are very, very, very careful about our drawing. So I'm going to, if you have a ruler available, you can. It's not a huge deal. And even with a ruler, it's a good opportunity for mistakes. So here we have a slope of 1 and a y-intercept of 1. In the second equation. So b is going to be 1, and the slope is over 1 up 1. Slope of 1 kind of looks like this. Now if we go back in time, boom, boom, I believe our intersection happens right there. And that point, if I zoom way in on it, that point is -2, -1. Back 2 steps, down 1 step. So I believe the answer to this question is -2, -1, like that. Pretty cool. 375 is going to ask us to simplify each expression below. Your final simplification should not contain any negative exponents. Okay, good. This is a good practice for the kind of the sub-skill going into our generic rectangle adventure. Here I see 5 times -3, that's -15. And we've got x to the third times x to the negative second. That's just going to be x, because 3 plus -2 is equal to 1. -15x is the answer there. No negative exponents, so we're good to go. Question 4. We're going to raise everything to the third power. 4 gets raised to the third power. P squared gets written to the third power. And Q gets taken to the third power. So what we have here, 4 to the third power, I don't expect anybody to know that off the top of their head, but use a calculator. It's 64. P to the second to the third is going to be 2 times 3 is to the 6th power, and Q to the third power is going to be the answer there. And now we have 3m to the 7th divided by m to the -1st. All we're going to do here is subtract. This is going to be 3 times m to the 7 minus -1, or 3m to the 8th power, and that would be as far as I want to go with that. And I believe that is the end of this assignment. Yes, excellent. Great. Hope you had a good time watching this video. Don't forget, you are awesome. You can do this. You are getting there a little better every single day. Right now, the generic rectangle is the thing that is the forefront of your knowledge. This is the thing I need you to be thinking about as you go through these problems. So you're doing great. Keep it up. I'll see you in the next video.